Hey everybody, Craig here, and today I'm going to be taking a look at something I'm very excited about, which is OKD 4.4 on oVirt. And now, of course, you've been able to use Openshift or OKD on oVirt for quite a while now, both as 3.11, which is the older series of Openshift, but also as a kind of user provisioned infrastructure. So OKD itself is if you're not aware of it, is the community kind of edition of Openshift. So the way that Red Hat generally model their projects and their products is each product has an upstream open source project. It just so happens that OKD is the open source community project for Openshift. Openshift being one of the largest enterprise container platforms based around Kubernetes that there are. So full disclosure here, I've been drinking quite a lot of the Kool-Aid around this. I love this product. It's probably one of my kind of main go-to things. I used to work for Red Hat, so there is the Kool-Aid. But yeah, I've been using OpenShift from, I don't know, 3.1 or something like that, way before I was at Red Hat even. And I just love it. It's a great platform. But I've been waiting for quite a while now for OKD to come for oVirt, because it seemed a bit strange actually that Red Hat had this OpenShift project, this product that would work on rivals and competitor platforms, things like vSphere, VMware vSphere, but not on Rev. It was just a bit weird. But they've finally gotten the community together. They finally put the engineering into this, and they've now got a nice it's an alpha release, a preview release of OpenShift on oVirt. And it's not just a user provisioned infrastructure installer either, where you've got to spin up your own VMs and spin up the place to put the ignition configs and all that kind of stuff. It's a full-on installer provision stuff. So we're going to take a little bit of a look at that today. So at the moment, OKD is in alpha, OKD 4.4. It's pre-release, loads of dragons, loads of bugs. Your mileage is going to vary depending on your infrastructure and your environment and how you want to use it. There's a couple of kind of, not really showstoppers, but a couple of things that you're going to run into as part of this. One is storage. Storage isn't existent yet for OpenShift OKD. It's not built into the main platform. However, the guys over at oVirt do have the CSI driver that they've put together. If I go back over here, which provides an implementation of the Kubernetes CSI driver implementation, which allows you to use oVirt storage just in the same way that you would use VMware storage or any other cloud provider storage. It will create a disk for you, attach it to the machine, and then that is consumable by your VMs, and it works really well. This comes in an operator form, and although there isn't really any amazing documentation for this yet. Again, this is alpha. This is a pre-release. It's not. I don't think they've even tagged it yet. That's how early it is. It does work. There's a couple of little weird bugs with it, but nothing that's kind of a showstopper. You can do useful things with it. So that's a storage one. The other issue that I've run into with this is around the oVirt engine itself. Now the oVirt engine, if I drop over to my oVirt console here and go over to the event stream, you can see here there's a lot of logins for admin internal going on. And they're roughly every 5 seconds, and these are generated by the OpenShift masters. There's a controller somewhere running, which I think it's the cloud controller, which is querying the oVirt as if it's a cloud provider, trying to get a sense for whether the machines that it controls are up, down, left, right, whatever, but getting the status. I think that's what's going on. But because of this, each time it's doing a login, it's generating a new session rather than using an existing session. And the knock-on effect of that is eventually the memory in the Java process is going to get the heap I don't know a lot about Java, as you can probably tell, but it's going to get exhausted, and eventually you start running into a bunch of API errors, and things like hosts look like they're not contactable and down, and lots of weird stuff happens. But it's purely because the way that Java works is it garbage collects to try and clear out some of the memory, and that garbage collection doesn't do anything. Like, there's so much stuff in its heap that it can't garbage collect quick enough to clear down some space, and it's all because of the number of open sessions. So that's something to look out for. Again, so there's bug tickets and issues and stuff raised for this. It's not news to them, and I'm sure it's stuff that they'll be working on and looking at in the due course, as we go through the alpha and go through the beta. But overall, it's nothing that's really going to stop you from working. I mean, you can the easy workaround here is you put a cron in and restart your hosted engine every couple of hours, or so, something like that. There's ways to work around it. Okay, so you've heard me mention IPI and UPI here. So UPI, or user provisioned infrastructure, is essentially when you bring your own tin, and so you don't rely on the installer to go ahead and create the infrastructure for you. One of the things that Openshift or OKD4 brings to the table is a fully revamped installer. For those of you that have kind of used Openshift 3 in the past, and you'll have run into a lot of issues with the Openshift Ansible installer. It's a really good, powerful tool. There's a lot there, and you can pick and choose bits and pieces of the component, but the bottom line is that installer was becoming there was too much of it that was happening above the waterline. So the platform was provisioned, and then there was a ton of stuff that was configured on top of that. And as we've kind of seen the operator kind of paradigm appearing, operators are taking an awful lot of the load off the installer, so the installer doesn't have to do half the stuff it used to. Right now, the installer, all it's got to do in the way that they've kind of come about here is spin up some infrastructure using Terraform, because it does bundle Terraform. It doesn't use Ansible, it uses Terraform now, to ensure that your masters and bootstrap nodes are there. Once they're there, it squirts some ignition configs into it, and then the cluster does the rest. The bootstrap node will do the actual setup and the installation to make sure that the initial etcd and all that kind of stuff and the initial masters are configured and built and work, and then it enrolls the masters into there, and then once the masters are in there, the bootstrap node say see you later, deletes itself, and away you go, and you've got a working cluster. And the masters from that point, and the controllers that have already been initiated on the masters, they go and do the rest. And it's awesome, because it means you've got such a slick mechanism for install and upgrade, and it's a lot better than what it used to be, where you used to have to test the Ansible upgrader in place, for every single cluster you've got, because something would always trip it up, and it was a lot more fiddly than this. So that's UPI. UPI is you bring your own infrastructure, versus IPI, where the installer will provision it for you. So rather than having to go and create all these VMs and a bootstrap node yourself, the install, you just give it your your oVirt or vSphere or AWS credentials, and tell it what template to use and a few other bits and pieces, and hit install, and away you go, and it will do the rest. And that's how I've installed this cluster here today. So storage wise, I mentioned briefly, so out of the box there's no storage. Typically with Openshift clusters, you'd expect to be able to utilize the underlying cloud provider's storage. So if you're deploying to AWS, you expect to be able to deploy EBS volumes. If you deploy into Google Compute, you expect to be able to use their block storage, and same for Azure, same for vSphere. You expect to be able to provision a disk and attach it to a node, and you expect the same for oVirt, because in oVirt 3 there's the Flex Volume driver. That doesn't exist in Openshift 4 or OKD4, because of the way that it's been designed, the way that each of the nodes are immutable, and the way that software is delivered and deployed onto them. That's not necessarily a bad thing, because one of the things that they give us as part of it is the ability to use the Kubernetes CSI interface thingamabob for disks. And what that means really to us, if we go over here, is for an oVirt cluster manager, is that you end up with you deploy an operator in a project called oVirt CSI Driver, and this operator gives you a couple, where it basically gives you a daemon set and a stateful set. So a daemon set is making sure that you've got a pod that runs on each of your worker nodes, so places where you're going to want to attach storage, and you've got the plugin, it's the stateful set itself. And this plugin is they're both important, but this is the one that's doing the hard work. This is the one that does the heavy lifting. And when you say, I'd like a PVC, please, it goes and provisions the persistent volume for you. It makes sure that the disk is created and all that kind of stuff, and then it's formatted in the right file system and all that kind of bits. Whereas the oVirt CSI node daemon set is making sure that that disk gets attached to the node, and it makes sure that it's mounted in the right place and available for your container to use. One of the things that I ran into is, and this is kind of a byproduct of the oVirt engine going away, is if the oVirt engine isn't available, obviously you don't expect your storage to do anything. You don't expect to be able to provision new machines. You don't expect to be able to attach or detach storage either, which is fine. But when the oVirt engine comes back, you also expect that to just start working again. There's a little bit of an issue at the moment, which again I'm sure the guys are going to sort out because they're on it. In that you end up needing to restart these pods. So if you do end up going down the path and having a bit of a play with oVirt, and you install the oVirt CSI driver, if you do start running into any weird issues like complaints that a PVC, when you try and mount it or when you try and use it within a pod, isn't a valid block device or something like that, it probably just means you need to restart these pods. That's probably it. But again, it's nothing major. Once you know about it, it's dead easy to fix, and it's dead easy to work around as well. Okay, so I've had to kind of script this because I've done this video twice now, and I kind of keep going off down a tangent on a garden path because I'm so excited about it. So next thing I want to show you really is kind of the dashboard. And for those of you that haven't seen or haven't used Openshift 4 before, Openshift 4 versus 3 gives you this whole nice new dashboard, and it's really good because there's a lot of kind of visibility of your cluster that you never used to have. So you wouldn't previously have seen all of your CPU memory stats like this. Monitoring and alerting was a particular pain point, whereas with Openshift 4 that's all built in. I can go to metrics and do some Prometheus query if I want. I can take a look at the dashboards, and there's built-in dashboards here to do things like monitor the health of your etcd cluster, things that are really important to a cluster. My new pod requests are going slow. Why is that? Well, you can see here clearly kind of what's going on with etcd. So okay, it's not etcd, what is it? You can do things like watching compute and all the rest of that for individual namespaces, or you can watch the CPU and memory, general utilization across your cluster, and you can start creating some nice bits and pieces of stats there, which is awesome. And it's really important as well when you consider that you've got a cluster to operate. How do you know when you're coming up to capacity? How do you know when you've got to scale up? And that actually brings me nicely. So from an end user, from a developer, you're going to be able to see this for your project. So if you go in to, if I go into a project which has some stuff, so I'm going to take a look at Eclipse, which probably isn't running properly, but purely just as a project, I can straight away see that I haven't got any events going on. My project is quite healthy. I can see the utilization here, so I can see I've got 6 pods, and that's not really scaling up or down. I can see how much network throughput is happening. I can see how much disk I'm using even, and so that's really awesome. I can even go back to 24 hours. There's probably a way of tweaking that so you can go back further or whatever, but you can see here that at this point I must have scaled up and then scaled back down again, and so you can quite nicely see what's going on and what your actual utilization is, which helps your dev teams to be able to actually plan things and be a bit more be good citizens on the platform. So that leads us again quite nicely into, so we talked about some of the dashboard and monitoring. That leads quite nicely into the scaling. So one of the beauties of installer provisioned infrastructure versus the UPI stuff, and I'm sure someone's going to correct me and say it's totally possible from UPI infrastructure to do some of this, to do the scaling in this way. But one of the beauties that I can see here is each of your machine groups, so our workers, the nodes that are going to be doing the heavy lifting here, they're defined as a machine set, and you can obviously create additional machine sets. Maybe you've got a machine set that sits in one subnet and belongs to one type of user. Maybe you've got another machine set that sits in your DMZ and just runs your routers. Maybe you've got a machine set that lives in another subnet and is for PCI workload. You know, you've got ways of mechanisms of breaking down these machine sets. Maybe one machine set has GPUs or something like that. But the beauty of this is if we go into a machine set, we're able to specify what that actually looks like. So we're able to say we want a number of these, which we can scale up, scale down. We can say that we want them to use a specific template inside of oVirt. So this is where I can't obviously find it. There we are. Template name. So if we've got a different type of worker, maybe you've got one that runs on a different network or something like that, or one that you have running SRIOV or something like that, SRIOV virtual machines, you're able to create another template in the background and then just point the worker machine set at that template. So next time it scales up a machine or provisions a machine, it'll provision from that. The other beauty here is we can start seeing some details of the workers and the nodes. So a machine it equals one node. So what we would have done previously with OC get nodes, you still do that nodes still exist. And they still give you kind of a role, and they give you kind of a view of whether your cluster's healthy, ready, from the Kubernetes view. But these machines also give us a view of whether the provisioning has happened correctly or not. So one of the nice things here is if I want to go here and say, not create machine, I want to go back to my machine set, please. If I say, okay, actually I want 7 machines, please. So I'll just change the desired count from 6 to 7. It'll say current count is 7, but the ready count is 6. So it's going to go ahead. And if we look here, and here we go, we've got a new machine appearing. And this is going to start going through the provisioning lifecycle. And that provisioning lifecycle involves talking to oVirt, and there we go, and provisioning a new machine from your template. So this has created it, and the actual process for scaling up the cluster isn't that slow actually. I haven't exactly got the best equipment here, but it only takes a couple of minutes really to bring a new machine in, which is, if you can compare that to kind of Openshift 3, where you had to provision your machine, you had to make sure that your machine was prepared, so make sure that Docker was installed and make sure that all the other prerequisites that you need for Openshift are there and in place. Then you can go and run the Ansible scale-up playbooks, which usually works, but sometimes there were issues, and sometimes you realized that you were missing a firewall rule, or there was a number of reasons why you would run into some issues. Whereas here, because everything is effectively a carbon copy of a template, it's I'm going to say idempotent. I'm sure that's not what I mean, but because everything is this carbon copy, it means that the only thing that Openshift is having to do here is spin up a new machine from this template, inject an ignition config to it, which, it's a bit like cloud in it. It'll tell it what its IP addresses should be, how it gets a network, where the masters are, how to contact etcd, all that kind of stuff. And once it does that, it will grab some containers from your registry. And in my case, I'm running a local registry so that it's a bit faster than running it from over the internet. But this whole process only takes a couple of minutes. I mean, right now this has been up a minute, and we should see that. So the machine itself is provisioned as far as Openshift, and very shortly we should start seeing that appear. That machine will appear in the list of nodes. So if we take a look here, the next thing I'm expecting to happen here is this machine that we've just brought in to reboot. So it'll pull down its config, it will pull down the machine, was it machine OS content or whatever container. So it'll update itself, and then it will reboot, and then it'll join the cluster. And it's quite a nice process. It makes it really easy, and providing you're kind of managing your thresholds well, you shouldn't be in a situation where you need to bring extra capacity into your cluster because your cluster's full. You can just click a button, it's just there. Or you can even start running autoscalers. So I've got an autoscaler configured here where my workers will, this autoscaler, if my cluster starts getting full, will chuck in some more workers for me. I don't have to do anything. It'll take it up to a maximum of 12. So again, it's quite nice, especially if you've got kind of a transient cluster where you've got a bunch of dev work that maybe happens mostly during the day. Maybe your devs are, they commit their codes, Jenkins spins up, scales out, adds more of its agents to the mix, and before you know it, you've got, I don't know, maybe 200 300 Jenkins agents running all at the same time doing plethora of tests. You don't want to be paying for that infrastructure all of the time. I mean, that's a bit of a moot point on oVirt, but on AWS or one of the cloud providers, you don't want to be having that tin running all the time. So it's quite nice. It'd be interesting to see actually if this would allow you to take advantage of spot instances. I think there is a Kubernetes operator somewhere. I've seen something somewhere which allows you to take advantage of spot operators and deschedule nodes. There's definitely a descheduler operator. I think I've seen one for spot instances as well for AWS. So that would be a good way of taking advantage of the scalable nature of Kubernetes and Docker containers, and also making the most for your money, especially on dev and non-production clusters. Let's get a bit more for your buck, a bit more bang for your buck. So here we are. The node, if we take a look here, is now in a not ready state. So that means that Kubernetes is now aware of it. So it's gone through the whole, I'd like a certificate, please. I'd like a new worker, please. Here's my labels, yada, yada, yada. And it's now going through a process of reboot. So within about another minute, that will be available for us to use. So overall, that's not bad. That's around about a 3-minute round trip that's taken. Not too shabby. Okay, so the last thing that I wanted to talk about, this will come ready, that's not a problem. The last thing that I wanted to talk about was kind of the dev experience. And if you're a developer and you've deployed workloads on an OpenShift 3 cluster, how does that kind of differ for OpenShift 4? Well, it's not too bad actually. So you've got a relatively familiar interface here where, it's got some new bits. It's got monitoring and compute and all that kind of stuff here that it's a little bit different. You've also got this operators section, which operators are great, by the way. They're a fantastic way of being able to deploy and manage applications in a kind of a truly DevOps way. And the reason that's probably a point of contention because DevOps is something different to everybody, and I firmly believe that it's a buzzword for communication. I'm sure everybody has a different definition, and that's absolutely fine. That is in itself DevOps. But this, for me, empowers a lot of DevOps behaviors because rather than having a central IT team, which is deploying, say, Eclipse Shea, in fact, this isn't a massively good example. Where's Keycloak? There we go. So rather than having a central team which will go and provision Keycloak instances for your dev teams or having dev teams manage it themselves, your central team provides a service in the form of this operator, which actually handles the installation, the upgrades, the provision. In this particular case, it handles the provisioning of some of the resources inside of Keycloak, so users and clients and realms, and also backups. These are all important things that every developer in your environment is likely to want, backups especially. And so it means that your central team is able to provide the service centrally, manage the process rather than managing the service. And that's a bit of a bit of a kind of strange distinction, especially when you've got teams that are kind of going from the old kind of chuck it over the fence kind of way of working, because they want to own the instances, but actually they don't have to. They just need to own the structure and own the framework and own the tooling that allows your teams, your development teams, your app teams, the people who are taking value to the end user, and allow them to work faster with kind of a bit more on their own. You're providing the guardrails, they're bowling. It's like a bowling alley when you've got the rails up at the side. They're chucking the ball down. You don't want them to go into the gutter. So your team, the central team, keeps the rails up. So it makes it quite a nice way of working. The other thing to look for here, if I go back to, so I'm going to go and create a new project. I'm going to call it AAA Test 2. So as a developer, I can go and deploy one of these operators into my project. Not a problem there. And it's literally just a clicky button type exercise. So keycloak, install, subscribe, and this operator will then be deployed into my project, so I can then go and deploy keycloak instance. And so if I take a look at keycloak and what it provides for me, well, if I want a keycloak instance, I literally just click that and click create, and it will go and provision keycloak for me now. And when keycloak is provisioned, I can then start configuring things like the realm, the backup, and client user, and all that kind of stuff, without having to interact with keycloak. So it means that I can put all of my configuration into code. So the other way, the kind of older way, and sorry, I did go off on a bit of a tangent there. The older way of being able to deploy your applications. So say you're a front-end dev, you've got a kind of standard simple application. It's maybe PHP or Python or Node or something along those lines, and a database. They're also, they're also dead easy to deploy. The flow isn't massively different. So in our case, we'll go from administrator. So there's a drop down kind of menu here which selects admin or developer kind of views. If you go into developer view here and then hit add, you can go over to from catalog. So most of these options here you're going to recognize from Openshift 3. If we go to from catalog, and then I tend to choose Cake PHP just because it's a really simple example, and it has most of the happy path in it. We do a build, we do some volume mounts, we create a route, we create a database, we create something with persistence. It does a fair amount. So if I go ahead and instantiate this, I'm not going to change anything about it. I don't need to. We can see that we've got a couple of deployment configs appeared here. One for MySQL, which is our database, and the other for Cake PHP, which is our build. Now, this is a bit of a different way of looking at things. We can see keycloak actually down here is in the process of deploying. That's what the little lighter blue circle's about. It's pulling. It's probably pulling. Let's click and take a look. Yeah, container creating. So the database for this is pulling, and probably same for that as well. So our new kind of end tier application, our database and our PHP front end, the database is pulling. So that's going to pull down from your local registry, or your remote registry, however you happen to have configured it. I just so happen to have a local central registry for speed. And in the meantime, we've got a build going on over here. So this is our web front end. This is the PHP part of the application. So clicking on the circle shows you the details. And so if we go and take a look, we're looking for resources and then build one is running. Let's go and have a look at the logs. So this is going and it's pulling down the code from GitHub. My connection isn't massively quick, so this is going to take a little while. But once it's pulled down the code from GitHub, it'll push it. It'll continue building it. It'll do what it's got to do. It'll push it to the internal registry, just as it has done on any other cluster that you might have worked on. And then it will do the deployment. We'll come back to this build because there's something else that I wanted to talk about real quick, which kind of links nicely, which is the internal registry. So OpenShift 3 comes with an internal registry. So does OpenShift 4, OKD 4. The difference is when you deploy this on oVirt, you need to actually enable it. So on oVirt, because oVirt doesn't come with any storage out of the box, you need to set up your storage provider, set up your storage class. So if we go down here, storage classes, we've got this default oVirt CSI storage class with the csi.ovirt.org provisioner that we've installed. You can install that from over here, by the way. If you go to the oVirt CSI Driver GitHub project and then go to deploy and chuck these and modify them, but chuck them into your cluster and they just work. There is some things that you need to change, but very little. So once you've got your storage set up, the next thing that you need to do is actually go and enable the image registry itself, because if you don't have any storage available as part of the install, then the image registry gets installed in kind of a disabled state. Now, it's dead easy to check this. If you go to administration and then custom resource definitions, and then we're looking for a config, here we go, a config custom resource. We want the config custom resource for image registry. So let's take a look at this. And this gives us that, this is the literally the custom resource definition for image registries. If we take a look at instances, that tells us how many image registries we're expecting. And now this one's called cluster, so you could create another one and have multiple registries if you want, because it's all controlled by an operator. If you'll run into this, that every aspect of Openshift 4 OKD 4 is controlled or managed by an operator, which is how I'll go into that a little bit more, but it's kind of how upgrades are a bit more seamless and how the install is a bit of a nicer experience for everybody as well. So if we go into this cluster config for image registry and then look at the YAML, this is going to give us a few bits here. So this is essentially the definition of what your registry should look like. There's a couple of bits in here that you got to change, and I'll go into a bit more detail in another video on how to actually do a full OKD cluster install on oVirt. But essentially what you need to look at here is the rollout strategy needs to be recreate. It's by default it is rolling update, and rolling update, because of the type of storage that we're using read write once. It'll never update, so you'll start running into issues where you've got two pods that are trying to take the same storage, but it can't because you're only allowed to read the storage once. It's a block device after all. So make sure you change that. The other is I change default route to true. I'm not 100% the impact of that. I believe it creates a route to allow this to be accessible from outside of the cluster, which is a behavior that I want in this particular case. You want management state to be managed. So this will be unmanaged or something like that out of the box. And finally, you want to specify your storage claim. So once you've gone into the project that this gets deployed into, which is OpenShift image registry or something like that, it's something image registry, you want to go ahead and create a storage claim. And once you've created that storage, you need to use that name in here and just specify PVC claim, and that's all it expects. If you leave, I believe if you just put PVC in, then it will automatically provision something, but it's not going to provision it with the right type of storage or necessarily against the right type of storage class. So just I prefer to do it by hand, because if we're having to modify this anyway, it's really like 2 seconds extra of typing to put in the claim name as well. The other thing to watch out for is the number of replicas. With the type of storage that we're connecting this to, it's read write once. You can only have one replica, you can't have two. The second replica will never start. So just bear that in mind as you're going. And so yeah, providing you've done that, your image registry is going to come up and everything should work happily. Until you do this, you're not going to have a registry to put any builds into. So when you're doing builds, if you're kind of just using one of the templates, the build's going to fail because it's not going to be able to push anywhere. Obviously, if you've got an external registry, or you're planning on deploying a different registry, or you've got some other plans or ideas on how you're going to deal with that, then there's no problem at all, because you've already thought about it and you already know how you're going to store your images and where your builds are going to go. But it's just something to bear in mind. So if we go back to our build, which is in AA2, And if I go to, where am I? Builds. Here we go. Our build actually failed. Now, why did our build fail? Ironically, it failed because of a registry issue. Okay, so the build happened. It tried to push it. I think this is because I've been messing around with push secrets, push and pull secrets. So that's probably related to that as opposed to anything else. But yeah, it looks like the registry isn't working. Let's have a little look. Let's see if we can do a little bit of debugging here. I won't go off too much at tangent, I promise. Openshift image registry, pods look healthy. Take a look at the registry itself, look at the logs. What's going on? Error putting, registry docker permission denied. Okay, yeah, this is probably a secrets thing that I need to tweak and tune. It's probably something weird that I've done because I've been messing around with push and pull secrets and stuff like that. So I think that's all that is. Not 100%, but if it's a new bug, it's a bug that I've literally just run into. Anyway, okay, so next, I think that was it actually. Oh, we'll go back to our machine and just check that that's actually provisioned properly. And yeah, there we go. Our workers, we've got 1, 2, 3, 4, 5, 6, 7 workers. If we go to machines, we've got our 1, 2, 3, 4, 5, 6, 7. And if we go to oVirt itself, this is our new worker, which ends in KBGFG. So nodes, KBGFG. Go into that itself, have a look at the pod. Oh, this is a nice feature as well. Before you used to have to go to the command line, do OC get pods or OC describe node in order to get the list of pods from a specific worker, but now you can get it in the interface, which is quite nice. So you can see that on our node here, this is the workload that's running, and you can see that it also includes all your system pods there. So there's nothing hidden here. It's everything that you want to take a look at. So in this case, it's actually, that's where it's decided to spawn our new registry. So that's quite nice. Okay, so that pretty much rounds it up for us. That was intended to be a really quick overview of OKD4 on oVirt and the kind of maybe some of the challenges and things that I've been looking and thinking about with it. Hopefully it's been interesting for you. If you liked it, do the kind of whole like, subscribe thing, tell your friends. If you don't, let me know in the comments. If there's something I could have done better, let me know in the comments. It's all massively appreciated. Anyway, thank you very much, everybody. Hope everybody is well. Thank you, and bye-bye.